A ratio is a comparison of two numbers using division. And you can express a ratio in three ways. You can either have like x2y, x and then a colon y, and then x over y. All three of these are ratios. Okay. A proportion is an equation that states two ratios are equivalent. Okay, so an example of that would be maybe 2/3 is the same thing as 4/6. 2/3 is a ratio, 4/6 is a ratio. These are equivalent ratios. So this would be a proportion. Proportions always have an equal sign. Now usually, like I said, ratios can be expressed in three ways. Usually when you're talking about a proportion, you express the ratio as a fraction. That's the most common way to do it. It's the easiest way. Okay, there are two ways to do this. And I think,
Cross multiply.
yeah, you can cross multiply. You can either look at this and say, okay, if I take 2 and I multiply it by 8, I'll get 16. And if I take 3 and I multiply it by 8, I'll get 24. And since these two numbers match, then yes, it's equivalent. So you can do it that way.
So you can
So
basically
2
go,
times
how many
8,
times 2 goes into 16?
yeah, is 16. 3 times 8 is 24. They match. So they are equivalent. Okay, so that's one way. Sometimes it's not always easy to tell, like what numbers you multiply by, because it might be that you multiplied by a decimal, and it might give you another whole number, but it's not so easy to find. So another way that always works is to cross multiply. So I'm going to do 6 times 5 and 10 times 2. So 6 times 5 and 10 times 2. This is 30, this is 20. This is not equal, so they're not equivalent. Okay, here I'll do 6 times 5 and 1 times 30. If I get two numbers that are equal, then they are equivalent. So cross multiplication is sometimes the easiest way. Sometimes it's really easy because you can just see it like, oh, 1 times 5 is 5, 6 times 5 is 30. But sometimes it's not as easy to just see what you would multiply by, so you can cross multiply. And if you get two numbers that are equal when you multiply, then they're equivalent. If it's not equal, they're not equivalent. Does that make sense? The inside parts, okay, these are called the means. Okay, they're the middle terms. Okay, and then the outside parts, these are called the extremes. Now it's easy to see which ones are the means and the extremes when you've got your proportion written with colons. But like I said, a lot of times this is the most common way that we see proportions. So when this happens, these two are my means. Okay. And these two are my extremes. Okay. So the product of the means must be equal to the product of the extremes. So these are my extremes, right? So I cross multiply. These are my means, so I would cross multiply. So for this to be true, 2 times 24 has to equal 3 times 16. Well, 2 times 24 is 48, and 3 times 16 is 48. So then this is true. Okay. If you have a proportion like this, 0.2 times 9 has to equal 1.5 times 1.2, because these are my 0.2 times 9 is 1.8, and then I don't 1.8. So that is true. Okay, so if you're presented this way, you multiply the two outside numbers and the two inside numbers. If you're presented as fractions, you cross multiply. I'm going to determine, are these equivalent? Do they form a proportion or not? Okay, so what you want to do is you put like a little question mark over the equal sign, because we don't actually know if they're equal or not. I just don't have the ability to type that. So we're asking, is this equal to this? Okay, so I'm going to do 2 times 14 and 3.5 times 8. So, yes. Okay. 0.3 times 2.0. 1.5 times 0.5. So this is going to be 0.6, I think. Yeah, and then so
And you can also tell because it's a bigger number, right? For the second term, your extreme.
not necessarily, right? You mean like this 2 and the 3? Whereas this is 1.5 and a 5. These are kind of close, actually. 1.5 and 2 is only half off of each other. And then 0.3 and 0.5 actually aren't that far off of each other. So it's not really... Sometimes it is extremely easy to tell, but with this one it wouldn't have been. Now, one way you can always tell is if I have an improper fraction and a proper fraction, there's no way these will be equal, right? Because this is larger on top. So you have to have smaller and large, you know, they have to be the same in that regards. So that won't work. Any questions? So we're going to use the cross multiplication to find out what x equals. Okay, because I know if this is true, then 5 times x has to equal 3 times 10. So 5 times x is 5x, 3 times 10 is 30. I'm going to divide both sides by 5, and I'm going to get x equals 6. Okay.
So yeah.
Well, no, there's not. It's not a yes or no here. We're going to say yes automatically because there's just the equal, and we're going to use the fact that it is equal to find out what our missing value is.
Oh, okay.
Does that make sense? Okay. And we're going to do the same thing here. Now, when this happens, when I have this x minus 2 times 7, that's distribution. Okay. And that's equal to 2 times 14, which is 28, right? So I've got 7x minus 14 is equal to 28, because I distribute that 7. So that's really important. When you have an expression, you have to multiply both parts by the 7, or whatever number. Okay, I'll add 14 to both sides. So I get 7x is equal to 35. No. Sorry. I was adding 7. Um, yeah, 42. Thank you. Divide by 7, and hey, looky there. I didn't do that on purpose, but x equals 6 again. So we have, in the past 2 years, a retailer opened 232 stores. So we have 2 years, 232 stores. That's a ratio. And if this rate remains constant, how many stores will the retailer open in the next 3 years? Okay, so we're going to do 3 years. And we don't know how many stores, right? So I'm going to call that X stores. So what my proportion is actually going to end up being. Now, it doesn't matter. I could have put stores on top and years on the bottom. So it can go like years, stores, or stores, years. That part doesn't matter, just so long as, see how both of the years are on top and both of the stores are on bottom? So you could have put both stores on top and both years on bottom. It doesn't matter which way they go as far as which one's on top, which one's on bottom, just so as long as they match. You can't have like years, stores, and then stores, years. They just have to match. Then once you've done that, you can cross multiply. So I get 2x is equal to 232 times 3, which is 696. I'm going to divide both sides by 2. And x is going to be 348 stores. Now that's not the only way to solve this problem. I could have figured out another way that I could have done it. So there's more than one way, right? I can say if she did 232 stores in 2 years, right? That meant she did 116 stores per year. And then I could have multiplied that times 3 years, and I would have gotten the same. Okay, so technically we're supposed to solve this with a proportion, but there's more than one way to do it. If you did this, I would not count that incorrect. As long as you can get to the answer, if you can come up with your own way to do it that's not the technical proportional way that we're doing right now, that's okay. Because this is algebra and there's more than one way to do it.
Is the part you put in the box the same thing as the one on the left?
Well, this is using a proportion to solve the problem. This is solving the problem by making a ratio, reducing it, and then multiplying by the number of years. So it's a different way to figure it out.
So that way it's a lot easier than this side.
Depends.
Why do you have that dash over the 348?
Oh, no, it's like meant to be an equal.
Oh.
It just didn't go all the way. It depends. For some people, this is easier. For other people, this is easier. It's just what way makes more sense. Okay, so scale is used when you make a model of something that you have it either be too large or too small to be convenient actual size. So like, you know, when they take a picture of like a microscopic organism and then they blow up the picture and put it in a book, that's to scale because we've enlarged it. Or if you take a picture of like an aerial view of the Grand Canyon. Obviously you cannot bring the Grand Canyon into the classroom, so you take a and you shrink it down. And it's always in proportion. So if something is like a mile long, maybe I make it 2 inches. But then that means that mile is equivalent to 2 inches. If I were to, like, if you shot it with a shrink ray, it would like shrink down, but it wouldn't like be all distorted. It would be in the same proportions. Or if something's really tiny, if you shot it with like a grow ray, it would grow into its natural proportions. A scale model is an actual 3D model. You see a lot of scale models with architects, and you see it on TV where the architect brings in like a scale model, like a white plastic
A
version
small
of the
version of it,
building
yeah.
that they want to make, or bridge or whatever. Those are scale models. Those are 3D. So scale can be used for like photos, maps, pictures, and 3D models, you know, but a scale model is 3D always. So like if I did a scale model of like a virus is microscopic, but like I would make like maybe a plastic
Big version of it.
model of it, yeah.
I seen you know how they
Is a map. Scale, like the most common reason you guys would use scale is maps. And it says like 3 inches equals 10 miles. That's the scale. So every 3 inches on that map is equivalent to 10 miles in the real world. And the length of the Ramsey Cascades Trail, if you look on the map and you measured it, it's a 1 1/8 inch. Okay? And we want to know how long is the trail. So if you want to put 3 inches over 10 miles, or you could do 10 miles over 3 inches, that doesn't matter. Just so long as you put the same proportion. So I want inches over miles, inches over miles. Okay. Now to make this easier, 1 1/8 is kind of hard to work with. So what I'm going to do is I'm going to go ahead and I'm going to find out what the fraction or decimal is. So I'm going to do 1 divided by 8, and that's 0.125. So I've got 3 over 10 is equal to 1.125 over x. Because decimals are easier to multiply and divide, right? So I'm going to cross multiply, and I get 3x is equal to 11.25. Okay? Every time you multiply by 10, you just move the decimal one place over. Divide by 3.
It says 10.
Miles, M-I.
Oh, M-I.
Yeah. Divide both sides by 3, and I am going to okay, so if you were looking on the map trying to figure out if you wanted to hike this trail or not, you could figure out that it's 3 3/4, 3.75 miles, so almost 4 miles long. So percent proportion, okay, percent literally means per 100%. So that means like if you have X percent, that's the same thing as X over 100. Okay, because it's whatever number it is per 100. So if you're going to take these percents and express them as fractions, so 79% would be 79 over 100. 107% would be 107 over 100. And if you wanted to, you could turn that into a mixed number, which would be 1 7/100. And if you have 0.5%, that's 0.5 over 100. Now, technically speaking, though, you cannot have a fraction in a decimal in a fraction. So when this happens, if I have to move this decimal one spot, I move one spot here too. And whenever I move, I put a 0 in. So this would be 5 over 1,000. Part over the whole is equal to the percent over 100. Okay. Okay, 40% of 30 is what number? This of 30, of whatever number is with the of is the whole. And whatever number is with like the is, that's the part. And then obviously this is the percent. Okay. So whatever comes with is, of, gives you the whole, is gives you the part. So another way you could look at this is instead of part over whole is equal to percent over 100, you could also say is over of. Okay, that's just another way to remember it. They're the same thing, just whatever works best for you. So if I want to set this up, this is my part. I don't know what that is, so that's X. My whole is 30. My percent is 40, and this is always 100. Okay. Now to make my multiplication easier, whenever I have this situation, I can take out matching zeros. Did anybody ever teach you that?
Nope.
Okay. Whenever you have zeros on the top and zeros on the bottom, like if I have 1 0 here, I can take out 1 and 1. If there's 2 and 2, I can take out 2 and 2. You can always just take out matching zeros. They cancel each other out. It's like dividing by 10. Which means I multiply smaller numbers, which is nice. So I get 10x is equal to 120 instead of 100x is equal to 1200. Yeah. Divide by 10. So x equals 12. So 12 is 40% of 30. You don't need to write this. This is all you really need, is x equals 12. If you don't want to use a proportion, is you can set up an algebraic equation, okay? Percent times whole equals parts. This is multiplication, because of is multiply and is equals. So I can say 6.75 is 75% of what number? So I can say 67.5 equals. Now if I do this, I have to take that 75% and I have to turn it into a decimal. To turn it into a decimal, I move 2 decimal places. Okay. So 0.75 times, I don't know what number this is, so that's x. And it could be that my x is over here, it could be that my x is here, but it's percent times whole equals part. So now I can divide both sides by 0.75. So I get x is equal to 90. Okay. Lunch survey. Woohoo. 42 out of 70 students said their family had a pet. Okay. What percent of students had pets? So I have 42, that's my part. 70 is my whole, and that's the same as some percent over 100. So I'm going to multiply 70 times x and 42 times 100. I'm going to get 70x is equal to 4,200. Divide by 70. And I'm going to get x is equal to 60. So that's 60%. Okay, the percent of change is, it's a ratio of change in an amount. Okay, and that's from an original, whatever your original amount was. And that's expressed as a percent. Okay. The percent increase happens if the new number is greater than the old number or original number. And you have a percent decrease if the new number is less. Okay, finding the percent of change. If you do the new number minus the original number, you divide that by the original number and you multiply it by 100, you get the percent. If the new was larger than the original, this will be positive. So that's a percent increase. If the new was smaller than the original, this will be negative, so that was a percent decrease. Now you don't leave the negative in there.
Is it even positive?
Yeah. So here's an example. If I take the new, I subtract the original, I divide it by the original, and then I multiply it by 100. So what that equals is 35 minus 27 is 8, divided by 27 times 100. Well, 8 divided by 27 is 0.296. 296.
Yeah, okay, we get it.
Yeah.
I don't know, what you keep repeating the same number?
Times 100. So 29.6%. And this was positive, so it's an increase. I'm just, like I said, I'm going to show you both methods, right? The other method you can use, you can do change divided by original is equal to percent. I don't know why that X keeps, I don't know why I did that. Cross that out. Is equal to percent over 100. Okay? So change over original. Well, if my original was 23 and my new is 0, or I mean 20, what's my change?
20.
Change is equal to new minus original, or original minus new.
So it's 3.
Yeah.
3?
Yeah, my change is 3, right? Because between 20 and 23, there's a difference of 3. So my change is 3. My original is 23. My percent, I don't know. And it's always over 100. So what I get is 23x is equal to 300 because I cross multiply. And then I divide both sides by 23. So I do 300 divided by 23, and I get 13.04%. Now, the thing with this is, with the other method, if it's positive, you know it's an increase. If it's negative, you know it's a decrease. This won't tell you that. So you have to just look, okay, this number was smaller. The new is smaller than the original, so this is a decrease. Because this is smaller. The number of cruises in North America increased 16% from 2000 to 2005. Okay, so if there are 192 ships in 2005, how many are there in 2000? All
So
right.
just put,
This 2005, that's going to be the new number, right? Because it's later.
there was 6.
The how many, we don't know how many there were. This will be the original number.
So can't you do 192 subtracted by 6? No.
No. This is my percent. So I either have to do method 1, which is
X.
new minus original over original times 100 equals percent, right? Or I can do change over original equals 16 over 100, or 16%. Neither of these is really fun because I don't have my original.
So
But
it would be X.
makes the change difficult. This one's going to be easier. So I'm going to do 192 minus x divided by x times 100 is equal to 16%, right? If I take this and I divide both sides by 100, I now have this set up, basically. So I have 192 minus x over x is equal to 16 over 100. Now I can cross multiply it. Okay. So we essentially are using this setup. It was just easier to figure this part out than this part right here. Or maybe you could figure that out really easily. Either way, we end up with the same thing. So I have 100. Here I'm going to do that so I can have more room. So what I have is 100 times 192 minus x is equal to 16x. That's from here, cross multiplying.
So I thought it was meant to the corner.
No, this is just moving up because it ran out of space. Okay, so I have 19200 minus 100x is equal to 16x. Because I've distributed the 100. So I have 19200 is equal to 116x. So I'm going to divide by 116. And I'm going to end up with x is equal to 163 more cruise ships. Oh, wait, no, it's not. I lied. Don't let me lie to you.
Alright.
I actually typed the wrong percentage, so. It's 165.5, so we're going to round it to 166.
You were only 3.
Yeah. Well, you know what I did? It's in the book, it's 18%. And I
There's
accidentally
160
typed
more ships.
in 2005 than there were in 2000. Now, it was 165.5, but you can't have half a cruise ship, right?
Mm-hmm.
So we had to round up because there's not half of a cruise ship floating around out in the ocean with people on it. It wouldn't work. Look what happened to the Titanic when it broke in half, right? I mean, it just...
It didn't.
Sales tax is a % increase in your price, right? Raises the price of your thing you're buying. Okay, so there are two methods I have to figure out tax, okay? Method one, we take our price. Okay, so first of all, we have to take that 7.25% and we have to convert it to a decimal. So I have to move this decimal place 2 spots. So it's going to be 0.0725.
Why did you have to move it to?
It's always 2 with percent.
Okay.
It's always, if you know how percent has 2 zeros? 2 decimal
so
places.
it doesn't be a percent, it has to go to the left, and it's to be going to be a percent, you go to the right.
Yeah, so you go to the left to turn it to a decimal, you go to the right to turn it to a percent. But it's always 2. So this is 0.0725. So I'm going to take her price, and I'm going to multiply that 0.0725, and that's going to give me her tax. So I've got 28.62 times 0.0725. So that's 2.07, and I'm keeping it 0.7 because I'm not having, you know, 4/10 of a penny or anything like that. Okay, so this was her tax, and then I take the price and I add the tax, and I get $30.69. Okay. So first, in this method, you first find the tax, and then you add it to the total, or to the price. Now method 2, you would do the same thing. You would take that 7.25% and you would turn it to a decimal.
No, just keeps it, oh, decimal.
Yeah. But what you do instead of these two parts, the method I use is I do the price, and I multiply that by 1 plus the tax. So I've got 28.62. So that's 1.0725. So you'll always put a 1 in front of your decimal, that's your tax. And when you multiply that out, watch what happens. I have 28.62 times 1.0725, and I get 30.69. So this 1 right here, that 1 accounts for one of these. So this is doing this whole thing, but in one step. Does that make sense? Because 1 is like a whole, and then your percent is your part. So when you multiply the price times 1 point the percent, or 1 point your tax, you get the whole total in one step instead of 2. But, you see, same exact answer, same exact thing. I don't care which method you use. If you like this method, use this method. If this method makes more sense to you, use this method. I just want to give you 2 options. Is that okay? Discounts are percent decreases.
Do you really get a decrease in insurance?
Yeah. Some insurance companies do that, yeah. They do good student car, you have to get like a form filled out from the school, but yeah, you can get a discount. Okay,
I wish I
so.
could get a discount on my insurance. It's ridiculous. I have to pay $230, almost $300, basically $284.
You're a
That's because part of my age.
boy too, yeah.
I have a 4-door car, but I didn't have a 2-door.
Okay, in either case, method 1 or method 2, you're going to convert to a decimal. Okay, you always have to convert percents to decimals before you can actually work with them, because you can multiply and divide decimals, you can't multiply and divide a percent. Okay, so his monthly payment without the discount is $85. So I'm going to do that $85. I'm going to multiply it by my 0.2. So I have 85 times 0.2, so that's 17. So it's a discount, so I'm going to subtract 17. So it's $68. Okay, that's method 1. So 2 steps. So here's our discount, and then you subtract it. Method 2 is very similar to the taxes. Instead of adding 1 though, I'm going to subtract from 1. So I have the price times 1 minus the percent decimal. So it would be 85 times 1 minus 0.2. 1 minus 0.2 is 0.8. So do 85 times 0.8. And I get $68. So, whatever way you like best.